Hello, we're going to take a look at lesson 3.5, equations of lines. We're going to look at several different equations today and working through different ideas. So here we go. Standard form of a line is in the form ax plus by equals c, where neither a nor b is 0. And you usually want them to be integers, and you want a to be positive. In fact, there's another part in here where it says you don't really want them to have common factors. So if you can divide everything by a number to reduce everything, you want to do that. X-intercepts and y-intercepts. So that was our kind of the first part of this lesson, x-intercepts and y-intercepts. X-intercepts are where the graph crosses the x-axis. That's just the definition. The x-intercept can be found by plugging in 0 for the y value. So if you want to find the x-intercept, you plug in 0 for y. Y-intercepts are where the graph crosses the y-axis, and the y-intercept can be found by plugging 0 in for the x value. The reason those things work out is because on the x-axis, the y value is always 0. Like you don't go up or down at all. And then on the y-axis, the x value is always 0. You don't go left or right at all. So here we have example 1. Use the x and y-intercept to graph 2x plus 3y minus 3y equals negative 6. Well, we can find the x-intercept by plugging in 0 for y. So it's going to be 2x minus 3 times 0 equals negative 6. Well, that's 2x equals negative 6 because this is 0. Dividing both sides by 2, we get the x-intercept of negative 3. And then we can also find the y-intercept, and we do that by plugging in 0 for x. So 2 times 0 minus 3y equals negative 6. This becomes 0. Divide both sides by negative 3, and you get y equals 2. That's the y-intercept. So now we can graph this. There's no graph given, so we'll just have to sketch one. And so we have an x-intercept of negative 3 and a y-intercept of 2, and connect those points, and you have the sketch of that line. All right, next section. Slope-intercept form of a line is y equals mx plus b, where m represents the slope, and we know slope is rise over run. Talked about that last class. Or we also learned that it's y sub 1 minus y sub 2 over x sub 1 minus x sub 2. And then b is the y-intercept, where it crosses the y-axis. So this example 2 says write 3x plus 4y equals negative 4 in slope-intercept form and graph. So slope-intercept form is right here. That means we want to get y on one side, everything else on the other side. So let's get to it. We want to get y by itself on this side, so we'll go ahead and subtract 3x from both sides. 4y equals negative 3x minus 4, and then we would divide both sides by 4. Dividing both sides by 4 is the same as dividing each term by 4. So y equals negative 3/4 x. 4 over 4 is 1, so minus 1. And it said graph using that form. Well, we know the y-intercept. So we start with negative 1. We start with the y-intercept. So there's the y-intercept, and then from there we can use the slope to find other points on the line. All we need is one other point. So negative 3/4, this is important to know. This could mean negative 3 over 4, or it could be 3 over negative 4. It cannot be cannot. It does not equal negative 3 over negative 4. That's a big no-no. So let's stick with this one. We can go up 3, 1, 2, 3, and left 4 would put a point there. We could go down 3 and right 4, which would put a point about there, and that would be the graph of that line. So we can graph lines. We can use x or y intercepts to help us graph, or we can use slope-intercept form to help us graph. And now we're going to write equations of lines. So write the equation of the line. Well, we know y equals mx plus b is the equation of a line. If we can plug in the slope and the y-intercept, we're all set. Well, the slope, we picked 2 convenient points, which a couple are picked for us already. So we can go rise 1 and run 1, 2. So rise over run times x plus the y-intercept. Well, it crosses the y-axis at 3, so plus 3. That's the equation of our line. Didn't leave much room here for this one. So write the equation of a line through the point negative 5, 6 with a slope of negative 1/2. Well, we can start with y equals mx plus b again, and we need the slope and the y-intercept. Well, we have the slope, but we don't have the y-intercept. We can't just throw in 6 and say that's our y-intercept. So the y-intercept has to have a 0 and then your y value. So what we do is we put this point in for x and y, and we put the slope in for m. So y, so in for y, we're going to put 6. So 6 equals m, which was negative 1/2. So we're going to plug in negative 1/2 for m, times the x value, which is negative 5. So we're going to put negative 5 in for x. And then plus b. And then we'll be able to solve for b. So we have 6 equals 5/2. Negative times a positive is negative, so 5/2 plus b. 5/2 is 2.5. That might help us just make it a little easier. Subtract 2.5 from both sides, and we get 3.5. And so now we have our slope and our y-intercept, so the equation of the line is y equals negative 1/2, the slope, times x plus 3.5. Example 4, according to the U.S. Lacrosse Annual Participation Survey, the number of youth players increased from 300,000 in 2009 to 400,000 in 2013. Write a linear equation modeling the growth of the sport. Well, we have normally a date is our independent variable. So it's actually written a little bit differently. So we have the time here, or the date, is going to be our x value, and the amount of people participating is going to be the y value. So we actually have 2 points here. 2009 is 300,000. And then the point 2013 is 400,000. Well, we can find the slope from the equation for slope, not just rise over run, but the y sub 1. So 300,000 minus y sub 2, which is 400,000, over x sub 1, 2009, minus x sub 2, 2013. And that gives us negative 100,000 over 4, over negative 4, which is 25,000. So that's our slope, and that in the meaning of this whole thing, that means it's growing at a rate of about 25,000 players per year, the increase. So that's our slope, and now we can say y equals mx plus b. We can put in one of our points. So let's just pick this one here. So y, which is 300,000, equals the slope, 25,000, times the x value, which was 2009, plus b. Well, we want to find b, so I'm going to go ahead and do 25,000 times 2009. It's quite a large number, so we have 300,000 equals, looks like it's 50 million, 225,000, oops. Plus b, and we're going to subtract that from both sides, so b will equal 300,000 minus 50,225,000. So interesting number here. This is, I'm going to have to give myself a little more room here. This is negative 49,925,000 is b. So the equation is going to be y equals m, 25,000, x minus 49,925,000. So you might think, wow, why is that such a large number? Well, this is, we're talking about the year 2009. So really this is, our y-intercept is kind of back at 0 BC, so that's why it's so low. So that's a line that would represent the linear growth. Might represent the linear growth in the last 10 years and maybe over the next 10 years, but you probably can't go any further than that for this to be a good model. All right, another one. Write the equation of a line through P parallel to K. All right, well, point P is at -3, -1. So we have a point that it goes through. And then it's parallel to K. Well, K, we learned what's important about K in parallel and perpendicular lines is the slope. So this slope of K is rise 1, 2, 3, 4, and a run of 2. So the slope is 4 over 2, which is 2. Well, if two lines are parallel, the slopes are equal, so we want the equation of a line y equals mx plus b. We can plug in the point for x and y, so -1 equals 2 for the slope, -3 for x plus b, add 6 to both sides, and you get b is 5. So our equation would be y equals 2x plus 5. And again, that's because parallel lines have equal slopes. So we found the slope of the line in the picture there, and that's going to be the slope of our new line. Another thing we could have done is we know the slope is 2, so we could have started with P, gone up 2 over 1, up 2 over 1, up 2 over 1, and we see that it would have crossed at 1, 2, 3, 4, 5. We have a y-intercept of 5. It kind of verifies our answer. Now, through P, but perpendicular to K. Well, perpendicular means the slopes are negative reciprocals. So the slope of the line in the graph was 2, while the slope of the line perpendicular will be -1 over the 2. So opposite reciprocal or negative reciprocal. And so we have the point. It goes through -3, -1. and it has a slope of -1/2. And so we can do the same thing. Y equals mx plus b. Plug in the point for x and y, so -1, and -3 goes in for x. We have the slope of -1/2 plus b. And then we solve for b. So -1/2 times -3 is 3/2 plus b. It might help to think of this as 1/2. Subtracting 1/2 from both sides gives us b is -2/2. So our equation is y equals the slope, -1/2 x minus 2/2. So there is the equation of a line perpendicular. So I know that was a lot of information. Use those individual examples to help you work out questions with graphing lines and writing equations of lines.